Hi there. Today, we are going to run through a realistic DevOps system design interview. This is the kind of conversation where interviewers are not just listening for the final architecture, but how you think, how you ask questions, and how you make trade-offs when the constraints are not perfect. I will ask you open-ended questions that mirror real interviews. Pause the video after each question and try to answer out loud before you listen to the sample response. If this format helps you practice for real interviews, make sure you subscribe so you do not miss the next session. Let's start with a few behavioral questions to understand how you approach system design problems in practice. Tell me about a time you were asked to design a system without clear requirements. How did you move forward? A strong answer might sound like this. In situations like that, I focus first on clarifying goals rather than jumping into architecture. I ask questions about expected users, traffic patterns, data sensitivity, and failure tolerance. Even if the answers are vague, they help narrow the design space. Once I have a rough picture, I propose a simple baseline design and explicitly call out assumptions. That gives stakeholders something concrete to react to, which usually leads to clearer requirements. I have learned that uncertainty is normal, and progress comes from structured questioning. Next question. Describe a time when your initial system design turned out to be wrong. What happened and what did you learn? A realistic answer could be, I once designed a service assuming traffic would grow gradually, so we optimized for simplicity rather than scale. Adoption happened much faster than expected, and we started hitting bottlenecks in the database layer. We had to redesign parts of the system under pressure. The lesson was that design decisions should consider not just current needs, but plausible future growth. Since then, I try to identify which parts of a design must scale well and which parts can stay simple. Next behavioral question. How do you handle disagreement during a system design discussion? A thoughtful answer would be, I try to separate opinions from constraints. If someone disagrees, I ask what risk they are worried about. Often we actually agree on the problem but differ on the solution. I also like to frame decisions in terms of trade-offs. No design is perfect. By discussing cost, complexity, and failure modes openly, the conversation becomes less personal and more objective. That usually leads to better outcomes. Next question. Tell me about a system you designed that had to balance speed of delivery with long-term maintainability. A solid answer might be, in one case, we needed to launch quickly, so we chose managed services and accepted some vendor lock-in. We documented those choices clearly and designed the system so core logic was not tightly coupled to the platform. That allowed us to move fast without painting ourselves into a corner. The key was being honest about the trade-offs and planning for future refactoring if the system succeeded. Final warm-up question. What do you usually do when you feel stuck during a design problem? A mature answer could be, when I feel stuck, I zoom out. I restate the problem in simple terms and focus on the most critical requirement. Then I design for that one thing first. Once the core is solid, the rest often becomes clearer. I also talk through my thinking out loud, because verbalizing assumptions often reveals gaps or incorrect ideas. Now let's move into the system design questions. Imagine you are asked to design a system that handles user-generated content uploads at scale. Users can upload files at any time, traffic is unpredictable, and reliability is important. How do you approach this? A strong answer could be, I would start by separating the upload path from processing. The upload endpoint should be lightweight and fast, possibly storing files directly in object storage rather than on application servers. Once the file is stored, I would publish an event or enqueue a task for processing, like virus scanning or transcoding. This decoupling allows uploads to succeed even if processing is slow. I would also think about retry behavior, idempotency, and how to handle partial failures so users are not stuck re-uploading large files. Next question. How do you decide when to add caching to a system and where to place it? A thoughtful answer might be, I add caching when I see repeated reads of the same data and latency or load becomes a problem. Placement depends on access patterns. Client-side caching helps reduce round trips. Application-level caches give more control over invalidation. Shared caches reduce load on databases but introduce consistency challenges. I also consider how stale the data can be. If freshness is critical, caching might not be appropriate, or it might need aggressive invalidation. Caching is powerful, but only when the trade-offs are understood. Next scenario. You are designing a system that must survive partial outages. Some components can fail without bringing the whole system down. How do you think about failure isolation? A strong answer would sound like. I try to design boundaries where failures can be contained. That might mean using queues between services, timeouts on all network calls, and circuit breakers to prevent cascading failures. I also think about graceful degradation. If a non-critical service is down, the system should still provide core functionality. Failure isolation is about accepting that things will break and designing so they break in controlled ways. Next question. How do you decide between scaling vertically and scaling horizontally in a system design? A realistic answer could be, vertical scaling is simpler and often cheaper in the short term. It works well when the workload fits within the limits of a single machine. Horizontal scaling adds complexity but provides better resilience and long-term growth. I usually start with vertical scaling to keep the system simple. When I see clear bottlenecks or availability requirements that a single instance cannot meet, I move toward horizontal scaling. The decision is guided by both technical limits and operational overhead. Next scenario. You are asked to design an internal API that multiple teams will depend on. What do you focus on to avoid future pain? A solid answer might be, I focus on clear contracts and versioning. Once other teams depend on an API, changes become expensive. I document request and response formats carefully and think about backward compatibility from the start. I also build in good observability so we can see how the API is used in practice. That helps guide future changes without breaking consumers. Next question. How do you think about data consistency in distributed systems when designing a new service? A mature answer could be, I start by understanding what level of consistency the business actually needs. Some systems require strict consistency, while others can tolerate eventual consistency. Strong consistency often comes with performance and availability costs. I explain those trade-offs and design accordingly. In many cases, eventual consistency with clear user expectations is the right balance. The key is making the behavior predictable and visible rather than surprising. Here is the next scenario. You are designing a system that serves users globally. Latency matters, but data correctness also matters. How do you decide which data should be global and which data should stay regional? A strong answer might sound like this. I start by classifying the data. Some data is naturally global, like user identities or account metadata, and other data is local, like session state or region-specific preferences. For global data, I think carefully about consistency requirements. If strong consistency is required, I might centralize writes and accept higher latency for certain operations. If eventual consistency is acceptable, I replicate data closer to users to improve read performance. For regional data, I keep it local to reduce latency and isolate failures. The key is making these decisions explicit, so everyone understands why some operations are fast and others are slower. Next question. You are asked to design a system that handles sudden spikes in traffic caused by external events. The spikes are unpredictable and short-lived. How do you design for this without massively over-provisioning? A thoughtful answer could be, I design the system to absorb spikes rather than react instantly to them. That usually means introducing buffering layers like queues or streams so incoming requests can be smoothed out. I also rely on auto-scaling where possible, but with sensible limits to avoid runaway costs. Caching helps if the same data is requested repeatedly during spikes. I also consider graceful degradation, where non-essential features are temporarily disabled under extreme load. The goal is resilience first, not perfect performance at all times. Next scenario. You are designing a system with multiple dependent services. One of those dependencies is slow and owned by another team. You cannot change it easily. How do you design around that constraint? A strong answer might be, I treat the slow dependency as unreliable by default. I put timeouts on all calls and avoid synchronous chains where one slow service blocks everything else. If possible, I cache responses or move calls off the critical path by using asynchronous processing. I also introduce circuit breakers so failures do not cascade. From a design perspective, I assume that dependency will be slow or unavailable at times and build the system so it can still function in a degraded mode. Next question. How do you approach designing observability into a system from the start? A mature answer could be, I think about observability as part of the architecture, not an afterthought. I decide early what questions we will need to answer in production, like where latency comes from or why a request failed. Then I design logs, metrics, and traces around those questions. I make sure each request can be followed across services and that key business metrics are exposed alongside system metrics. Good observability reduces guesswork during incidents and speeds up debugging dramatically. Next scenario. You are designing a system that must handle schema changes over time without breaking clients. How do you plan for evolution? A thoughtful answer might be, I assume schemas will change, so I design for backward compatibility from day one. That means making fields optional where possible and avoiding breaking changes. I version APIs and data formats explicitly and give clients time to migrate. I also monitor usage of old versions so we know when it is safe to deprecate them. The goal is to let the system evolve without forcing synchronized deployments across teams. Next question. You are asked to design a system that processes sensitive data and must meet strict compliance requirements. How does that influence your design choices? A strong answer could be, compliance affects everything from data storage to access control. I design with least privilege in mind, ensuring services only access what they need. I encrypt data both at rest and in transit and make sure key management is well defined. I also think about auditability, making sure actions are logged and traceable. Sometimes this adds latency or complexity, but those trade-offs are necessary to meet regulatory requirements. I try to make compliance part of the architecture rather than something bolted on later. Final question for this section. How do you evaluate whether a system design is good enough to ship, even if it is not perfect? A realistic answer might be, I look at whether the design meets the core requirements and whether the risks are understood. No design is perfect, so the question is whether the remaining risks are acceptable and manageable. I also consider how hard it will be to change the system later. If the design allows iteration and learning, I am comfortable shipping it. Waiting for perfection often delays feedback that would make the design better anyway. Let's move into the final section of this interview. These questions are intentionally uncomfortable. They are designed to see how you think when the system is imperfect, the information is incomplete, and the cost of being wrong is real. Here is the first scenario. You are asked to design a system quickly for a major launch. You know the design is not ideal, but leadership wants to move fast. You also know the system will probably need to be reworked within 6 months. How do you decide what corners are acceptable to cut and which ones are not? A strong answer might sound like this. I separate short-term compromises from long-term risks. I am willing to accept technical debt if it does not threaten data integrity, security, or core availability. I document every shortcut clearly so the team understands what needs to be revisited later. I also make sure the design can evolve without a full rewrite. What I do not compromise on are things that are hard to fix later, like data models, security boundaries, or failure isolation. Speed matters, but only when the blast radius of mistakes is controlled. Next scenario. You are in an incident. Traffic is spiking, latency is climbing, and multiple components are under stress. Different team members are proposing different fixes, some risky, some conservative. You have to choose a direction quickly. How do you make that call? A mature answer could be, I prioritize actions that reduce load and risk first. I look for reversible changes like rate limiting, feature degradation, or traffic shaping. I avoid making large architectural changes in the middle of an incident unless there is no other option. I also make sure one person is driving the response to avoid conflicting actions. Once the system is stable, we can revisit longer-term fixes. During incidents, my goal is not elegance, it is survival and recovery. Next question. You design a system that works well at launch. 6 months later, usage patterns are completely different than expected. The system still works, but it is inefficient and expensive. How do you respond? A thoughtful answer might be, I view this as a normal outcome, not a failure. Assumptions always change. I gather real usage data and compare it to the original design assumptions. Then I identify which parts of the system are now over-engineered or under-optimized. I propose incremental improvements rather than a full redesign, unless the cost savings or reliability gains justify it. The key is being willing to adapt the design based on reality, not defending past decisions. Next pressure scenario. You are asked to simplify a system design to reduce operational burden. However, the simplified design introduces a single point of failure that did not exist before. Leadership is comfortable with the risk. Are you? A strong answer could be, I would not accept the decision silently. I make sure leadership understands the failure scenario clearly, including the impact and recovery time. If they still accept the risk, I document the decision and add mitigations where possible, such as monitoring, fast recovery procedures, or backups. My role is to surface risk honestly, not to block decisions. Once the risk is understood and accepted, I focus on making the system as safe as possible within those constraints. Final pressure question. You are designing a system, and two good designs emerge. One is simpler and easier to operate. The other is more complex but more resilient. There is no clear right answer. How do you choose? A realistic answer might be, I look at the team that will own the system. A highly resilient system that no one can operate safely is not actually resilient. If the team is small or less experienced, I lean toward simplicity with clear failure modes. If the system is mission-critical and the team has strong operational maturity, I might accept complexity for better resilience. The best design is not just technically correct, it fits the organization that runs it. That brings us to the end of this system design interview. These questions are meant to reflect how real interviews work, where clarity is rare and trade-offs matter more than perfect diagrams. System design is as much about judgment and communication as it is about technology. Take a moment to think about which question challenged you the most. Was it deciding what to compromise under time pressure, choosing between simplicity and resilience, or leading decisions during an incident? If you found this useful and want more practice with realistic interview scenarios, make sure to subscribe so you do not miss the next session.